Hey everyone, welcome to my new lecture. Today we are going to solve exercise number 4.3, factorization and algebraic manipulation. Let's start with question number 1, part A. Part A states that we need to find the HCF of the following monomials by completing this table. So here in the first part, we're given a monomial which is 16p cube q, comma 9p q square r. So firstly, we have two terms. The first is 16 and then we have 9. Are these two terms divided by a single number? So no, they aren't, because the first is an even number, the second is an odd number. So we will just take 1 as a common value. Then we have p cube and here we have p. So we're gonna take the least common power. So it will be 1p. And then we have q and q square, so we will just pick q. And then r is located here, but it isn't here, so we won't consider it. So this is the HCF of our first question, part A. Now let's move on to the second monomial, that is 10p power 3 q power 2 r power 4, comma 28p power 3 q r square, comma 7p square q r square, comma 21p square q square r power 4. So here we have the values 10, 28, 7 and 21. These all values are divisible by the number 7. So we'll take 7 as a common value. So here we are going to write 7 first. Then we have p cube, p square and p square. So we're going to take the least common power. It will be 7p square. Then we have q square, q and q square. So we're going to take q as it is the least common power. Then we have r power 4 here, r square and r power 4. So we're going to take r square. So this is our HCF for monomial number 2. Now let's move on to the third monomial. It states that if all the common factors with at least the power of 3 unknown polynomials are 2 power 3, 3, pq and p plus q whole square, then what would be their HCF? So basically in question number 1 part B, there is a question that says that we have an unknown polynomial. We have 3 unknown polynomials and these are their least power. These are their least power common factors. Now they are saying if these are the least power common factors, then we need to find their HCF. So we're basically going to multiply all of these terms. We're going to multiply all of these. So we have 2 power 2, that is equal to 4. So 4 will be multiplied with 3 and then multiplied with pq and p plus q whole square. So for 3's are 12. So I'll just write 12 pq and I'll write p plus q whole square as it is. So this is our answer. So this is our HCF for 3 unknown polynomials of exercise 4.3. It says that we need to write any 2 polynomials of our choice having the HCF as 1. So we're gonna write any 2 polynomials whose HCF is 1. So we can say that x plus y whole square, comma x minus y whole square, or even we can say 100, comma 1. So these are 2 polynomials having the HCF as 1. Why? Because they aren't related with each other. They can't be divisible by a single number. Both numbers can't be divisible by a single number. So this is the answer. You can write any polynomial of your choice. Then we have part D. Part D states that we need to okay, it states that the only common factor of two polynomials is m minus 1. So we have two unknown polynomials and their common factor is given, which is m minus 1, and they say that the uncommon factor of this polynomial is m square plus n square. Now they are saying, can you guess the unknown polynomial? So if we want to guess the unknown polynomial, we are going to multiply the HCF with the uncommon factor. So here we have m minus 1 and we have m square plus n square. So we will write m minus 1 and then we'll write bracket m square plus n square. So we are multiplying these both terms. So this is our answer for part D. Now let's move on to part E. They are saying, can you guess the HCF of two polynomials if the polynomials are? So this is our first polynomial, which is x cube. It is x cube plus 5x added with 1, and the second polynomial is 1 plus 5x plus x cube. So we have basically two quadratic equations, you can say, and they are saying we need to find their HCF. So here in the first equation we have x cube. If we pair it up with x cube here, so that means x cube is a common element, so I'll just write x cube here. Then we have 5x. If I pair it up with here 5, so that is also a common element, I'll write 5x. And then we have 1, so I'll pair 1 with the 1 over here, so we also have a common element. So our final answer will be x cube plus 5x plus 1. So this is our HCF. Now let's move on to question number 2. Question number 2 states that we need to find the HCF of the following by factorization. So here the first is x plus y whole square, and then I'll write it below. We have x square minus y square. So first, x plus y whole square is equal to x plus y. We will just write it 2 times over here. So x plus y and x plus y. And then we have x square minus y square. If you remember that we learned the third identity, which was a square minus b square, it is equal to a plus b and a minus b. So I'll just format this into that form. So I can write x plus y and I can write x minus y. So here we have x plus y whole square and x square minus whole square y whole square. So I just simplified these two. Now what will be the HCF? Here we have x plus y and here we have x plus y. So these both will be common. We'll take them as a common factor. So I'll just write that the HCF is equal to x plus y, and this is our final answer. Now let's move on to question number 3. Question number 3, it's exactly the same. We have a minus b whole cube. What is a minus b whole cube equal to? So we will just write a minus b 3 times. After writing it 3 times, then in the second part we have a quadratic expression, which is a square minus 2ab plus b square, also equal to a minus b whole square, the second identity that we learned. So here if we simplify it much more further, it will be a minus b and a minus b 2 times. It will be a minus b. It will be a minus b 2 times. So here we have the first expression simplified and here we have the second simplified. So what will be the HCF? So here a minus b will be considered as a common factor and a minus b. So I'll just write below that the HCF of question number 3 is equal to a minus b. So this will be our final answer. Now let's move on to question number 4. Question number 4 states that we have a cube b minus ab cube, and then we have a power 5 b square minus a square b 5. So what are we going to do first? So look at the first expression. We have a cube b minus ab cube. So we are going to take the common values between them. First we have a cube, then we have a. So I'll just take a. So I'll write is equal to a. Then we have b and we have b cube. I'll take b. So ab bracket. This will be a square minus b square. So look, we have ab bracket a square minus b square. Now what is a square minus b square equal to? Yes, it is equal to a plus b and a minus b. So this is how I simplified a cube b minus ab cube. Now what about the second part? Here we have a power 5 and a square. So I'll take a square as a common. So I just write here, I'll write it here. I'll write a square, and then I have b square and b power 5. I'll take b square as a common value. So we have a square and b square. So bracket will be applied. Then we have a power 5 divided by a power 2. That will be equal to a power 3. B square and b square will be cancelled. Then we will have b power 5 divided by b power 2. That is b power 3. So here we have a cube minus b cube. Now if you remember the formula that we learned in the previous exercise when we were attempting it, the formula for a cube minus b cube was a minus b, a square plus b square plus ab. So I'll write this first, and then we have a square b square. Instead of a square b square, we can simplify it and we can write a b dot ab. So this is exactly the same. So I have simplified these both expressions. Now what is the common between them? So here we have a minus b, and here we also have a minus b, so we can consider that as a common. And here we have ab, and here we also have ab, but ab is with a plus b, so we won't consider it as a common value. So here only a minus b will be considered as the highest common factor. By this, what is the square root of 49? It is 7. So we can simply write x square minus 7 square. Now we have this into a square minus b square form. We will just apply the formula. That will be x plus 7 and x minus 7. Now the second factor that is given is x square minus 4x minus 21. So by taking a glance at this expression, we can say that it's a quadratic expression. So we need to find the factors. Assuming the coefficient of x square is 1, so 1 multiply negative 21 will be negative 21. So what are the factors of negative 21? So if we take negative 7 and multiply it with positive 3, that will also be equal to 21. So we'll take negative 7 and 23 as our factors, because when we subtract them, the resultant is negative 4. So I'll just write here x square, and then I'll write negative 7x plus 3x minus 21. Then I have these 4 terms. I'll make 2 pairs out of them. So I'll take x as a common value, x bracket x minus 7. Then I'll take 3x minus 7, and then I'll write x minus 7 and x plus 3. So here I have simplified this quadratic expression too. So above we have x plus 7 and x minus 7. So x minus 7 and x minus 7 here will be considered as common factors. So I'll just write the HCF is equal to x minus 7. So this is our answer. Now let's move on to question number 6. Question number 6. Question number 6 states that we have 12x square plus x minus 1. So look, this is also a quadratic expression. The coefficient of x square here is 12, and here we have negative 1. So 12 multiply negative 1 is equal to 12 multiply negative 1 is equal to negative 12. So we need to find the factors of negative 12 such that we will have 1 for x. So that is 3 multiplied by 4. So I will write here 12x square, and then I will write plus 4x minus 3x minus 1. Now I have 4 terms here. After achieving 4 times, I'll just pick the common between them. So that will be 4x, 3x plus 1. I can say 1. Then I'll write here minus 1 bracket 3x plus 1. So this is our factors. I need to simplify it much further. So 3x plus 1 and 4x minus 1. This is our first factor for the first part. Then in question number 6, the second part states that we have 15x square plus 8x plus 1. Now this is also a quadratic equation. We need to simplify it also. So 15 multiplied with 1 is 15, and we need to find the factors of 15. So when we add them up, the resultant will be 8. So 3 5s are 15. 3 multiplied by 5 is 15. If you add them, that is equal to 8. So I'll use 3 and 5 as my factors for this quadratic equation. So I'll write 15x square plus 5x plus 3x plus 1. After writing that, I have 4 terms here, so I'll just pick 5x and then 1. So I'll have 1 bracket 3x plus 1 here, and then I have 3x plus 1 as the first factor and 5x plus 1 as the second. So now I need to find the HCF between them. Here we have 3x plus 1. So this is common in the first and this is also common in the second. So HCF of question number 6 is 3x plus 1, and this is your answer. Now let's move on to question number 7. In question number 7, we have c square x square minus d square. So firstly, c square and x square, it can be written as cx whole square, and d square can be written as just d square. So now we have compiled this into a square minus b square form. So now what do we need to do next? We will write cx plus d and cx minus d. So this is our first factor. And the second part of question number 7 is acx square minus bcx plus adx minus bd. So let's simplify this. So firstly, acx square will be multiplied with adx and bcx will be multiplied with bd. So let's arrange them first. So I'll just write it is equal to acx square plus adx. After that, I write minus bcx minus bd. After arranging them, we are gonna pick the common values between them. So here common is a, then we have x as common. So I'll just write ax bracket and then I can write cx. After that, I'll write plus d because a and x are going to be cancelled, and then we have minus minus, so I'll write minus, and then we have b here and b there, so we'll just pick minus b as a common. So I can just write cx minus plus as plus and d. So now we have cx plus d. So the first factor will be cx plus d and the second factor will be ax minus b. Now I've simplified these both expressions, so let's see which is the common. So here we have cx plus d. I'll take this, and then if you look below we have cx plus d. So we can conclude that the HCF of question number 7 is equal to cx plus d. Now let's move on to question number 8. In question number 8, we have m square minus n square. So m square minus n square, it is equal to m plus n, and it is equal to m minus n. Then the second expression is m power 4 minus n power 4. So we can simplify it as m square whole square, and then we can say minus n square whole square. Now here we have compiled this into a square minus b square form, so I can just simply write m square, which is our a, this is our a, and n square is our b. So m square, I'll just write m square added with n square, and then m square will be subtracted from n square. This is our second factor. Then we have m power 6 subtracted from n power 6. So if we simplified this, we can write it as m power 3 whole power 2, and we can write it as n power 3 whole power 2. It is exactly the same, just expanded. And then what do we need to do? This is in the a square minus b square form. We will write m cube plus n cube, and then we will write m cube minus n cube. So here we have simplified all of these terms. Now as you can see, you might just take a look and say that there is no HCF common, but here we have m square minus n square, and m square minus n square is equal to m plus 1 and m minus 1. So the HCF of question number 8 is, we can write HCF of question number 8 is m square minus n square, or it is also equal to m plus n and m minus n. So this is our answer. Now let's move on to question number 9. So question number 9, we have three separate terms here. So the first is ax square being added with 2a square x, then plus a cube. So let's solve this first, and then we are going to solve the second. So here we need to pick what is common. So what is common between them? We have a here, we have a here, and we have a. This is a square and a cube, so I'll just pick a as a common value. Then I can write x square plus 2ax plus a square. Now after writing this, what can I do next? We realize that this is a quadratic expression. Here the coefficient of x square is 1, so 1 multiplied by 1 is equal to 1, but if we add them up, they are equal to 2. So we are gonna use 1ax and added with 1ax as our factors. Okay, so I can just write a bracket x square plus 1ax added with 1ax plus a square. After writing that, we have four terms. We're gonna make two pairs out of them. So a bracket x plus a, and then I will write plus a bracket x plus a. So I'll just close this right here. So now I have a bracket x plus a, and then I have x plus a again as my second factor. So this was the first part. Now we have two left, so let's do that too. I just label this by 1, so I know this is the factors found for the first. Then I'll write a cube. No, it is not a cube. 2ax square minus 4a square x minus 6a cube. Now what is the common between these three? So first we can see that 2 is can be divided throughout, so we'll take 2 as a common, and then we have a and a, so we'll pick a. So 2a bracket, and then I'll write x square minus 2ax subtracted from 3a square. So this is our quadratic equation. Now we need to simplify this too. So here the coefficient of x square is 1, Now we need to find the factors for this quadratic equation. So 2a bracket x square will remain the same, but we will have 1ax here and negative 3x there, subtracted from 3a square. Now what do I need to do next? Make pairs for these terms. So I will have 2a bracket, I'll pick x. After picking x, I'll just write x plus a. After writing x plus a, I will just pick negative 3a, and I can write x plus a here too. After doing that, I'll just pick here 2a bracket x plus a and x minus 3a. So this is the second factor. Okay, now we need to find the last factor. So we have written after the comma 3 bracket ax plus a square whole square. So how will we simplify this? Okay, so here firstly we have ax plus a square whole square, so we can write this as 3a into a. Then we can write x plus a into x plus a. After writing that, this is our third factor, so let me arrange it right here. HCF is equal to a bracket x plus a, because here we have a bracket x plus a, then here we also have a bracket x plus a, and in the above we also have a bracket x plus a. So this is our final answer for question number 9, and exercise 4.3 has been completed.